And with that, it's my pleasure to introduce today's topic, which is an introduction to ThreatMapper. If you're not familiar with ThreatMapper, by the end of the presentation, you will have learned how ThreatMapper can help you augment your security practices, and you'll have seen it in action. And with that, let me turn it over to today's presenters. We have Sandeep Lahane, founder and CEO of Deepfence, and we have Owen Garrett, head of products and community.
All right, thank you, Michelle. All right, so hi everyone, super excited to be here in this, our first session essentially on ThreatMapper. Allow me to go ahead and introduce the company, what we do, and then I'll hand it over to Owen to speak about ThreatMapper, essentially the problem it is trying to solve, how we solve it, how this is different, how to use ThreatMapper, and all of that really. So Deepfence is a cloud-native security observability platform. We look at cloud as a continuum. It's essentially all of these modalities side by side. You've got Kubernetes, you've got serverless, you've got VMs, and we look at this as a continuum. We don't really need point solutions for, or point, products for each of these modalities. So it's a continuum, and that's how we look at it. But today, more specifically, we're going to talk about our signature offering called ThreatMapper that we launched at KubeCon a couple of weeks ago. ThreatMapper essentially bridges the gap between developers and the operators, essentially, really, right? So you scan in CI/CD, you've got thousands of vulnerabilities, and at runtime, you really don't know what to do with all of these vulnerabilities, really, right? So because everything can't be fixed, that's where ThreatMapper comes in picture. Sort of helps you bridge that gap. It really prioritizes stuff that matters. Briefly, ThreatMapper works across multiple cloud. So you've got AWS, Azure, GCP, fret not. We're going to be able to sort of visualize all of this for you. It also figures out multiple modalities like pods, containers, Docker, VM, what have you. So it's multi-modality, multi-cloud, platform that works. And with that, I'm going to hand it over to Owen to speak about the actual problem statement, how we go about solving it. Owen, over to you.
Sandeep, thank you. Hello, everybody. It's great to be talking with you today. I'd like to start off with a little bit of an analogy to illustrate the problem that we're facing as an industry as we build and deploy and operate modern applications. The picture that you see in this slide is of the Titanic. I imagine we're all familiar with the story of the tragedy of the Titanic, but I'd like to share a little bit about the genesis of the ship. I grew up near Belfast, near the Harland and Wolff shipyards, where the Titanic was built just over 100 years ago. And she was and still is one of the proudest things that the Northern Irish industrial complex has created. Northern Ireland had a great history of shipbuilding, and the Titanic at the time was the culmination of their expertise and their ambition. The most sophisticated, highly engineered, luxurious ocean liner of her time. And if you speak to anyone who was connected in any way through history to the Titanic from Northern Ireland, they will tell you she was fine when she left us. She was well engineered, well designed, to the point of almost being unsinkable. She was fine when she left us. The fate that befell her was an operations problem, a security and observability problem. And this is so similar and familiar to the problem that many of us face as we build modern applications. We build them to an extremely high standard. We engineer them using the best possible techniques. We push them into production, confident that they are secure and able to face whatever the internet and the world throws at them. But then responsibility for those applications moves across to the production, operations, and app security teams. And the difficulties and challenges that these applications can face in the real world, the changing world, the changing security posture can create threats and issues that we never would have known about at production, at development. Let's dive down and look a little bit more into some of the threats that applications face and how shift-left processes can address many of those, but are not a complete part of the solution for operating modern applications. We'll look at the problem. Applications today, a very large majority of them are based to a very great extent on third-party open source components. Up to 90% is commonly reported as the application code percentage that comes from third-party open source components rather than has been developed and tested by the developer, the enterprise themselves. But when you push one of those applications into production, you then have to take responsibility for the security and the integrity of the entire application. Not just the 10% that you have created, but also the other 90% of code that's pulled in from other open source and third-party dependencies. Typically, an average of over 500 open source dependencies in an enterprise application, according to a report from Synopsys, who also recognized that of those dependencies, 84% of them had at least one vulnerability extant at the time of testing. Those vulnerabilities are published through organizations such as the National Vulnerability Database by MITRE. Over 18,000 vulnerabilities were published last year, and we're up to 17,000 this year. The number of vulnerabilities detected in third-party components is only growing as organizations seek to use more components and developers build and iterate faster. Over 50% of those vulnerabilities are potentially high or critical, according to White Source. And other types of attacks happen against the software supply chain. Impersonation or substitution of third-party modules, compromising CI pipelines. Many thousands of software supply chain attacks can compromise the integrity of applications before they're pushed into production. And the response from the industry has been a very wise one. The response has noted that the cost of fixing issues in software is significantly lower the earlier on in the process you can fix those issues. Based on research from IBM from many years ago, this has created what is now known as the shift-left movement, where the burden of building secure applications, testing for security, moves to the development team as far left as possible. The challenge that the development team faces is to scan and secure their applications as early as possible, fixing bugs as soon as possible, so that, like the Titanic, when the application is pushed into production, it's known and proven to be tested and sound and as free as possible from known vulnerabilities. But this shift-left movement, extremely valuable as it is not enough to secure modern applications. There are many limitations when you just look at shift-left as a way of solving the security problem. Not all vulnerabilities can be patched before production. A late-breaking vulnerability may not have a fix. The fix may be too costly to integrate and test. The engineering team may make a very qualified and sensible decision that a particular vulnerability is probably not exploitable within their particular application and code stack, so they're comfortable with that vulnerable code moving into production, being confident that that vulnerability is not exposed. Third-party resources on which your application depends. Network technology, ingress controllers, third-party plugins such as for monitoring or log handling or alerting, or indeed the infrastructure itself that you deploy your application code onto. None of that typically gets the same level of scrutiny that your own application does through a shift-left process. But nevertheless, all of those are also potential ingresses for attack against your application. And most importantly, vulnerabilities continue to be discovered at an alarming rate. GitHub's research indicates that it can take 4 years before a vulnerability is detected in published code, and a further 12 weeks to then remediate that vulnerability and push out a fix. That means that even though an application with its dependencies is pushed into production, vulnerabilities could be discovered long after that application is deployed into production. We saw that exact situation with Equifax and Apache Struts. Equifax's breach happened because of application components that were tested and believed to be secure and pushed into production before the Apache Struts vulnerability was identified. 2 months later, an attacker identified that Equifax were running in production components vulnerable to Struts, and that resulted eventually in the compromise of 143 million customer records and a cost to Equifax in excess of $1 billion to remediate the shortfalls in their security. And just last month, 120,000 Apache web servers running in production were found to be vulnerable to a path traversal exploit that gave an attacker access to any file on the file system that the Apache process was able to read. All of the great security and vulnerability scanning that shift-left processes do, the responsibility of shift-left begins to end once a component moves into production. And this has real implications. Red Hat surveyed their OpenShift customers and found that only 6% of their customers were confident to say that there were no security incidents related to containers and Kubernetes in the last 12 months. Most customers reported issues around misconfigurations, incidents during runtime, or vulnerabilities at runtime. And these, of course, are only the vulnerabilities that the customers were able to observe and were prepared to report. The challenge comes because the relationship between the development and DevOps teams and your application security teams who are responsible for the production platforms, that relationship is misaligned. Dev and DevOps care about innovating quickly and bringing new features into production to improve and extend the applications and services that your business, your enterprise delivers to its customers. Their key target is to accelerate that process and bring new features to market faster and faster with every release. Individual dev and DevOps teams focus 100% on their own applications. They typically don't take a global view where they consider all of the applications that an enterprise is running. They are laser focused on iterating on their applications. And other than developing the code itself, they look to automate everything they possibly can so that it happens in the background and they can focus on what for them brings the most value to the business. They are not able in that context to prioritize a long list of theoretical vulnerabilities that require investigation and may or may not result in a potential exploit in an application that they've created. On the other hand, once an application is running in production, responsibility for the security and the integrity of that application typically sits with a separate team. It may be platform operations or operations. It might be SecOps, it might be app security. It goes under different names. But this team is responsible for the global reduction of exposure to risk that the enterprise suffers from. They look to understand and minimize the attack surface across all of the applications that the enterprise is running and publishing. And they take that global responsibility across all the apps and services. They typically are not laser focused on individual applications or individual services. Although they may automate many parts, they typically have a much more manual, investigative approach to the work that they do, spending time researching exploits, researching vulnerabilities, researching the behavior of attack groups, and threat hunting within the applications that the enterprise is hosting. From their perspective, developers can tend to operate too quickly, be a little bit slapdash, and they don't always take adequate concern adequate time to look at security concerns. On the left-hand side, Dev and DevOps are looking to accelerate the DevOps infinity loop, to iterate as quickly as possible, to develop, test, release, deploy, and then iterate back again to develop new capabilities. And on the right-hand side, the application security team are sitting at the end of the pipeline with responsibility for the production systems, looking for vulnerabilities and weaknesses, identifying typically amongst the users that we talk to, tens of thousands of potential vulnerabilities across an entire infrastructure. On individual hosts, hundreds or more potentially exploitable vulnerabilities from weak dependencies and potentially compromisable software packages, 100 or more on each individual host. And with thousands or tens of thousands of containers running in production, each of those containers having a number of potential vulnerabilities. And as we mentioned, many of these vulnerabilities may be deployed into production under the knowledge or the confident assumption that they are not exploitable. But with this volume of data, how can you possibly drill down and give the dev and DevOps teams the actionable information that they can work from in order for you to reduce your attack surface as quickly as possible? This is where ThreatMapper comes in. And I'd love to hand across to my colleague, Sandeep. And rather than listening to how it works, let's see in real life how ThreatMapper can be used to identify issues running in production.
Sounds good. Thank you so much, Owen. I'm going to go ahead, share my screen. All righty. You should be able to see the screen here. All right. Thank you so much, Owen, for that background. What I'm going to do, everyone, now is I'm going to show how the continuity from the shift left scanning, from the CI, from the CD, registry scanning, let's get some of that, sort of addressed first, and then I'll speak about why it is essential to be able to build that visibility, that security observability across your production infrastructure, across multiple modalities. So what you're seeing here is the dashboard, the main dashboard of ThreatMapper, which is essentially, you see here, there are multiple workloads which spread across multiple clouds. Let me go ahead and get back to the multi-cloud view. You see here, there are a few workloads, two cloud providers. You see Google Cloud, you see DigitalOcean. There are 9 containers running out of a 38 container images, 6 hosts, 2 Kubernetes clusters, 2 namespaces, and 6 pods. So this is essentially, your entire cloud estate here in this particular case spread across 2 different clouds. ThreatMapper not only is visualizing all the compute, for example, not only the VMs and Kubernetes in the serverless, we're also visualizing the third-party services. For example, if you're running a RDS instance or Elastic Cache, you're going to be able to see that. So third-party services, third-party APIs as well, because your app really is code, compute, the APIs that you call into, the APIs that you're exposing, all third-party services that you're really using, all of that really, right? So it really starts by being able to visualize all of this. And you see there is an S3 bucket being called into, there is a Cloudflare API, somebody's pulling a, calling a Slack hook. This is really where it starts, being able to visualize everything that you're running within your infrastructure. And once you visualize this, there are a couple of ways to go about it. First, of course, is a graph view. This itself will scale to a few thousand nodes. I think the largest we've seen is about 25,000 pods across 12 Kubernetes clusters. So this scale is pretty sizable for a sizable infrastructure. You can visualize this as a table as well and really dig deeper all the way from your cloud to your regions to the hosts, from the host all the way down to the molecules, which are your processes. So you can look at your infrastructure as a graph or as a table, hierarchical table, really. So for example, I'm just going to click on a few and essentially go, you've got a few hosts here, you've got a Kubernetes cluster, you can really dig deep and then really start looking at actual pods. You can click further, see what exactly is running there. all the way down to the process level, really, right? So that's first part, really being able to visualize what you have running. Now, with that, now that we have taken a short, quick overview of what you can visualize and why being able to visualize everything that you're running is super important, let me go back to some of the continuity that you require in scanning. For example, you have Jenkins plugins, you've Circle CI or Shippable, one of those, sort of CI/CD pipelines where you can use ThreatMapper to scan your artifacts even there. So let me go ahead and open the ThreatMapper GitHub. You're going to be able to see all of those plugins listed here. So you can do that as well, right? You can scan it from the CI/CD pipelines. You can scan from registries as well. For example, most of the common registries that we have seen we are integrating with. We keep adding to this all the time. So some of the cloud specific registries, AWS ECR, you've got Azure. I think in this particular case, we're going to take a look at how a Docker Hub integration looks like. So you're going to be able to list all the images within your Docker Hub registry. You're going to be able to scan them. You're going to scan individually. You can scan them as a cron job. You can do a batch mode scan. You can say scan whole of my Docker Hub registry every 24 hours, right? So all of those multiple ways are possible. An individual developer or ops practitioner can actually go and scan only the images that they need to, or they can scan the whole entire container registry as well periodically. That's the first part. Second part, of course, is being able to scan it at runtime. Runtime scanning is super important because some of the context that Owen mentioned earlier, like, is this dependency actually being used by a process? Is this dependency actually loaded by a process? This particular jar or this particular .py file, which has a vulnerability, is anybody actually using it? Otherwise, what is going to happen is you're going to be looking at a pile of inactive, unexploitable vulnerabilities, really, right? So it's super important to look at that. So let me go ahead and kick off a few scans and how that overall looks. So I'm just going to go ahead to one of the agents here, one of the nodes in Google Cloud. You're going to be able to see all of this data. The connections, this is real time, by the way. This refreshes every 3 seconds. It sort of lets you, play with your infrastructure, operate it in an interactive manner. And you're going to see all the details like this. And coming to scanning, essentially, you can go ahead and say things like this. I want to scan this entire Kubernetes cluster for Java vulnerabilities because we are predominantly using Java. Or you can go ahead and say, you know what, scan every executable piece of code, no matter which language, which framework, within this entire cluster or on this particular host. So you can do all of that. And then the scan will be kicked off. All the results will basically be populated. And this is, by the way, the scan is not a network scan. We're not going to saturate your network bandwidth by scanning. This is Deepfence itself is deployed as a microservice. You can see here, it's a container, takes minimal resources. It is deployed as a daemon set along with your containers. So yet another daemon set that you're sort of deploying along with your services. It's not a proxy. It's not a kernel module. We do all the tracing that we do using eBPF and other services without affecting any sort of adding any performance penalty or slowing you down. So that's really the first part. And when you scan, the vulnerabilities really are populated like this in this particular screen. You see two screens here. One is most exploitable vulnerabilities, and I'm going to talk about that. But let's take a look at the scans that we initiated earlier. So all the scans you did, be it at a container image level, be it at a host level, you're going to be able to get scan results like this. Yesterday you scanned, you've got 5 vulnerabilities, let's say. Today you scanned, you've got 6. You can actually look at the diff between various scans, go and see what really changed. What is that new package? What is that new build that you did that essentially added one more vulnerability? And then you can dig deeper. You can say how many of these are Python vulnerabilities, how many of these are in base packages. For example, the apt-get install core utils, for example, right? If there's a vulnerability in the base packages, you're going to be able to see that. You're also going to be able to see the language and stack specific vulnerabilities. And here is how the details are going to look like. Let me go ahead and click on one of these. Here you see this is a vulnerability in a package called pip 19.2.3. This is the version. It's actually going to tell you where this particular package resides on the file system. Is this vulnerability in a host or in a container? So this is particular container in which this vulnerability is there. What is the image ID? What is the container layer in this particular, where this vulnerability is found? So you can actually go back and see when this was injected, what build caused it, and then sort of take a, remediation step from there. Container name, of course, you've got a CVSS score as well. The actual description. Now, oftentimes what happens if a CV is disputed, you don't know where this is fixed, right? You have a CVE, the data is the details are there on NVD or the vendor specific, CV report. For example, in this case, it's on the Red Hat Bugzilla. You can actually go there and see why this is a CVE, how bad it is essentially from exploitability point of view. Very often, in cases where the CVs are not disputed, you will actually see what to do to fix this, really, right? So, and super importantly, what is the attack vector? What is the attack complexity? Can somebody exploit this vulnerability remotely, or somebody has to log in to be able to exploit this, really? All of these details are required for you to go and essentially take an action on this. For example, this one is exploitable over network. Now, this is something that you need to really worry about because this is remotely exploitable. And what Deepfence does is, let me go back here and show the list of most exploitable vulnerabilities. This is where it gets super interesting, because this is where we are really using the runtime context of, hey, is that particular container image in which this vulnerability is reported, is that even running? Is that host in which we have vulnerabilities that even online? If it is online, is it taking network connections? Is it accepting traffic from outside world? How long ago this was built, this particular image? If this container image was built 6 months ago, chances are that it is more exploitable now. How many is this in a base image? Really, we look at a set of 8 to 10 conditions which tell you how exploitable this is. So out of the 493 vulnerabilities, you really need to be able to prioritize and say, you know what, I am going to fix this one right now because this is going to hurt me immediately. Why? Because this is in a running container. It is a remotely exploitable vulnerability, and the container is actually doing network IO at this point in time, right? So, and this is not a CVSS score. This is an exploitability score that we compute based on all of these runtime parameters. So think of it as this way, right? In CI/CD, in registry scanning, you've got 500 vulnerabilities. But how do you even sort these based on, prioritize these, and what should we even fix initially? Just CVSS score is not enough. It's a static score. You need more runtime context to be able to score this properly, which is what we do here, right? And then the same vulnerability starts looking sort of, you have prioritized it. You can go ahead and fix it. You have all the details to fix it. Why do you fix it? Because it's immediately exploitable now. So that's about vulnerabilities. So you've got two details. One is, of course, per scan details, and of course, what do you really do with each of these vulnerability? What do you start with? So that's that. Quickly, I'll also speak about the integrations that we have built. You can generate XLS reports. You can generate PDF reports out of these vulnerabilities. They could be very granular. You can say, hey, this container is owned by this particular team. These 5 images belong to this particular team. Let me generate a report for them, just for those 5 containers, right? You can do that. You can generate an XLS report as well. And apart from that, you can get notification on Slack, on PagerDuty. You can get an email. If you have any homegrown, sort of log collection or SIMs based on ELK, for example, you can, send all of this data there. You can get notified on Teams. You've got, SIM integrations. We keep adding more and more, and all of this is going to be in open source as well. You can file a Jira ticket as well. So you can say this particular vulnerability is immediately exploitable. Let me go ahead and file a ticket and assign it to appropriate team members. You can do all of that from ThreatMapper, which is an Apache V2 project that we launched a couple of weeks ago. All right, so I think that's pretty much I had from my side on a quick walkthrough of ThreatMapper. Owen, back to you.
Thank you, Sandeep. So if I can share the screen, what I'd love to do is to share with you what we're planning for the roadmap for ThreatMapper. So we've got some Sandeep has shown some really exciting capabilities in ThreatMapper that are available right now. ThreatMapper is built based from a product that Deepfence have been developing and using in production for a couple of years. And we're going through a process of taking the core, most exciting technology in that product and open sourcing it with a goal of creating a ThreatMapper open source platform for security observability. The first open source release came just less than a month ago, announced at KubeCon, and that was the release which Sandeep was showing you in the demo. In that release, ThreatMapper is able to discover the topology of the applications running on your infrastructure, supporting multiple clouds, so querying Google, Azure, Kubernetes, Fargate, serverless, and other environments to learn the topology, what is deployed, and then retrieve manifests from those deployed objects and the underlying hosts to, as Sandeep showed, identify vulnerabilities that may be present in those individual components. And then finally, put all of that information together, prioritizing vulnerabilities based on their exploitability. Are they, for example, network exploitable and receiving traffic from the outside world in order to build a threat map? This capability you can get from the ThreatMapper open source platform. You can pull it directly from our GitHub repository. And there's a couple of really exciting capabilities that we'll be adding to ThreatMapper over the next few weeks. Now, Sandeep, maybe you could talk about some of the improvements we're making around the most exploitable vulnerability.
Absolutely. And this one is my favorite, Owen, as you know. We were really bringing this whole exploitability metric down to a process level. I mean, think about it this way, right? Here is a package which is known to be vulnerable because the scans told you so. But at runtime, we're going to be able to actually track the loads, the opens of those dependencies and tell you, you need to go and fix that PHP file, a PHP vulnerability right now, because here's an attack path coming from internet to the Nginx and directly going to your PHP service, let's say, for example, which has a locked and loaded vulnerability ready to be exploited, really, right? So bringing it down, narrowing it down from host to containers and containers to processes. So what you really end up with is out of those 750 vulnerabilities that you have across your infrastructure, you need to really focus on these 5. Why? Because at runtime, you can actually see what attack paths are, potentially going to be hurtful, and essentially what are those packages really. So this is really overlaying the runtime context that we have with the scan data and telling you, ignore those thousands of vulnerability, just focus on these 5 immediately because they are exploitable, and here is an exploitability path or attack path really. Yeah.
Perfect. So it's clear this is not your grandfather's security tool that just relies on network scanning. This is a security tool that is very closely aligned with the way that the DevOps and development team look at the artifacts that they're deploying into production, and it gives them direct actionable information on exactly where they need to look in order to address a security vulnerability. Well, of course, security vulnerabilities don't just come from vulnerable components that we may have linked into applications. We're also looking at some compliance capabilities, aren't we, Sandeep?
Well, absolutely. I think known misconfigurations or cloud infrastructure misconfigurations continue to remain one of the biggest attack vectors. Known badness like vulnerabilities, absolutely, but known misconfiguration, hardening issues, certainly. I think this is going to be a next very interesting feature that we're going to release in ThreatMapper, which is, hey, is my Kubernetes cluster sys compliant? Are these VMs on which I'm running some of these critical services, have they been hardened for PCI DSS, right? So really taking those, templates, those controls, each of these compliances mandate, and applying them infra-wide, be it Kubernetes, be it Fargate, be it serverless, be it VMs, all of that. That's the next one which is coming in. Yep.
Brilliant. So together, these make ThreatMapper a really capable product to identify at any one instant where security vulnerabilities might exist in your application or in your production environment, in your Kubernetes or cloud environment. But that, at the time, information is just one half of the picture. The next thing that users need from a security and observability platform is an understanding of what is happening in real time that may indicate that an application is under attack, that a user is deploying a recon operation, that an exfiltration is happening. And the next stage of our roadmap brings in a large series of runtime sensors. Again, these are capabilities which are already present in earlier Deepfence products, and we'll be moving these into the ThreatMapper platform over the next 3 to 6 months. The ability to identify resource anomalies. Is there a spike of traffic or a spike of CPU that's unexpected within a container or on a host? The ability to identify indicators of compromise, to look at the processes that are running within a container or on a host and identify if a process is misbehaving. Unexpected crashes, unexpected process creations, or a process running a system call or operation that it probably shouldn't be, like a tracing operation. We can pick all of these indicators of compromise up against processes and also against file systems. Is the process modifying files on disk that it should not be touching? These are all very strong indicators that a workload has been compromised, that an attacker has found a way to make it do something it's not intended to do. But the most exciting capability that we have coming in the ThreatMapper open source platform is the ability to look at the network and also pick out indicators of attack. The very, very subtle, quiet signals that say that someone is roaming within the application, is trying to look for vulnerabilities, the indicators that are precursors to an attack. And Sandeep, I know that you and the team have been working for a long time on building out some really innovative capabilities based on eBPF that are able to get insights into how an application is performing.
Well, absolutely. I think eBPF is truly the next superpower on which security and observability, the whole industry is going to be using that. We've been doing a lot of work on eBPF for a number of years now. It really starts with being able to give you that insight, which is just not possible from anywhere else, really. For example, one of the features we were speaking about is, hey, is this particular jar file, is it loaded in memory of a process? If yes, it's exploitable now. This sort of detail is just not possible in a CI/CD scan. It's just not possible in scans, network-based scanners or agentless scanners, really, right? Because all of this is so much deeper runtime context you can collect using eBPF. And then all of these thousands of vulnerabilities, you can really narrow it down to a handful. That's where we are really releasing the first sensor. In addition to that, there is a lot more which is basically about being able to observe ingress traffic, egress traffic. And this is completely out of band, essentially. With a proxy, you can do all of this, but then they slow you down. And where do you put a proxy in a serverless environment, really, right? So we do all of this without a proxy, without a kernel module, so much so that we're going to be able to do actual content inspection, actual deep packet inspection of traffic, even if it's encrypted, right? Of course, that's I think a topic for a separate session, but essentially think of the sensors that we're going to bring in ThreatMapper will let you monitor what comes in, what goes out, what changes across time and space, across multiple clouds.
Thank you, Sandeep. And our play is an ecosystem play. Our intention is to create the most capable open source platform for security observability, to identify the, at this time, potential vulnerabilities and compliance issues and create a threat map, but also to capture and provide runtime information around resource anomalies, indicators of compromise, and indicators of attack. And then to make this information, this data available through a series of open APIs so that other ecosystem solutions can then consume and act on this information. We hear from a lot of users that are really excited about the potential of taking this information and feeding it into their own SIEM systems, or feeding them into Elasticsearch or ELK or other kinds of analysis tools, in order to then look at it themselves and build their own tooling around understanding what's happening within their application, processing the observability events and improving security. And this platform will be successful if we see other organizations building other solutions on top of this, other ecosystem solutions that rely on the data that we can extract from this platform. Our roadmap is based on taking a lot of the existing technology from the Deepfence products that have been developed to date and moving those across to build out this open source platform that combines vulnerability scanning, compliance scanning, runtime sensors, and then provides the data through a platform API. We have some fantastic technology around correlation and protection that can act on this data, but with an open platform, with open APIs, of course, there's the capability for anybody in the community to build tools that can benefit from the data that we are able to capture and provide. So you might ask, how can I get started with ThreatMapper now? I've seen the roadmap. I can already see the value in scanning at runtime to discover and identify what is running in production and to inventory that for vulnerabilities and issues. I can see how this already complements the shift left capabilities that I've deployed and the other products that I'm running. I like the fact that it's lightweight. It's deployed using lightweight sidecar agents and processes. It fits well within my infrastructure. How can I go about getting and trying out the ThreatMapper capability? ThreatMapper is and always will be 100% open source, licensed by the Apache 2 license. You'll find us in GitHub, Deepfence/ThreatMapper. You'll find us in Slack. Please join our Slack channel. If you need help, if you've got suggestions, reach out to us in Slack. Or indeed, if you come across issues or you have product ideas, let us know through GitHub. How can you deploy ThreatMapper? It's deployed in two parts. The largest part is the management console that you saw Sandeep use during the demo. That management console you can deploy with a Docker Compose operation, grab our Docker Compose file, away you go, and immediately you're up and running with the management console. And then deploying the agents into your production systems is a simple and non-intrusive operation. Those agents then call back to your management console, keeping your data private and safe. And together, that solution allows you to visualize, to understand, to scan, and to build a threat map for the services that you and your developers have deployed and are running in production. So folks, thank you very much for your time and attention. Shift left, but remember to secure right. Would very much like to take any questions or any feedback. Use the Q&A session, the Q&A box, and I'll take a brief pause to hand back to Michelle and grab my breath. And then Sandeep and I are very happy to address any questions that you may have.
Great, great presentation, Owen and Sandeep. That was really nicely done. We have set aside 45 minutes for today's Tech Talk, and we are now at 10:45 my time here in San Francisco. So if some of you need to drop off, we hope that you enjoyed the session today, and we will be sending a copy of the recording so that you can revisit if you would like. And for those of you who can stick around, we already have several questions in the Q&A box. We will be happy to answer those and any other questions that may come in. With that, I see here, Sandeep, you've answered.
Did answer, yes, one question. There are a couple of questions I see, Michelle. I'll go ahead and take those, Owen. Everyone, the first question is, can we support multiple platforms at the same time, be it cloud, serverless, VMs, or do you need a separate Deepfence install for each? To answer this question is, we'll look at cloud as a continuum. You're going to need only one Deepfence install across all of these modalities. Even if you have hybrid cloud, multi-cloud, you got it all covered with one console. So essentially one Deepfence console, which is the GUI, and then multiple sensors, which you sort of drop across to your infrastructure. They start reporting back into the same console. So this is going to work even across these modalities. The second question that I see, Michelle, and everyone here is, how is this different from agentless scans? A great question, actually. And there is a little bit of a theory behind this that I want to sort of start with. Agentless basically could mean two different types of scan. One is, of course, the traditional network-based scanning, wherein the sensors would discover whole your infrastructure, essentially fingerprint the applications, the hosts that are running, and really look for vulnerabilities. That is how it was being done for so many years. That was a network-based scan. The second agentless scans, which are up and coming, is basically snapshot-based, where you can snapshot, you're running VMs, or look at the EBS storage and cloud, and then essentially scan those snapshot completely in an offline manner without affecting your infrastructure. So that's essentially the second type of scan that is sort of coming under the agentless category from what we are seeing. Now, both of these are great technologies, except one thing, that they lack some of the runtime context that you would need, or that you can get only if you have something like an eBPF probe running along with your services, which is really looking at all these molecules, all these dependencies, all this interaction between processes, what's loaded, what's really, exploitable, which is what we do. So think of it as network-based scanning. Again, great technologies. In fact, some of the agentless techniques are really about using cloud APIs to enumerate your compute, enumerate your storage, and being able to scan it from afar, really, right? So some of these same techniques we use, for example, all the cloud services we saw, we enumerate cloud to get essentially, but our scanning is not snapshot-based. Our scanning is based on some of the runtime things that we see. We believe that runtime context lets you go that additional, build that additional observability, which is not possible from afar, really, right? So if a network-based scanner or an agentless scanner is giving you, let's say, 1,000 vulnerabilities, the same 1,000 vulnerabilities, something like Deepfence, which is using runtime context, helps you bring it down to a handful. Why? Because it's looking at various things, but which I mentioned, like, is that being used? Is it really exploitable? Is there a network connection? The actual behavior of the system at that point in time, all of that stuff, really. So we're complementary to those scans. Those scans give you quick, instant compliances, but for anything deeper, you would need something which is using eBPF or something which is really sitting with your workloads to be able to scan. Great question, by the way.
Okay.
Michelle, that's pretty much what I see here on my screen. These are two questions I see.
There's a third one. It looks like you typed in your answer, though. So if that's all on that one, then it looks like all questions have been answered at this time.
Yeah.
Great. Well, thank you so much, everyone, today's presenters, and also all of the attendees. If you have any questions, reach out anytime. We have a community Slack, which you can find on our GitHub. We're there to answer questions as they arise. So thank you again for your time today. And with that, we will officially end today's Tech Talk.
Thank you so much. Thanks, everyone.
Thank you. Bye.
Thank you.
Bye.